Thank you so much, Michelle and everybody. This is really fun. You're a very nice crowd. I've never done anything like this before, and not that I've never spoken to an audience before about this topic, but never this type of audience. And I think you'll see from my slides sort of how our background is really in green policy and climate ocean change, mitigation and adaptation strategies, and that there's a big group of marine people that are thinking about climate change and some climate people that are thinking about ocean issues, but there's really little crossover in that kind of community of practice. And so being able to chat with groups like this and learn so much already just from those intro presentations are great. So I'm just going to talk a tiny bit about the Ocean Acidification Alliance. That is what I have the privilege of being part of, and we are a group of governments, national governments, as well as state and city and regional, provincial, who are thinking about how we talk about ocean acidification as an impact of carbon emissions, as a cause created by carbon emissions, and how we want governments at global, regional, and local scales to think about better measuring and responding to acidification. And so the way that we even try to get governments engaged in this topic is, what is ocean acidification? And generally, we are trying to paint a bigger picture for them about climate ocean change or climate ocean impacts. And so, the preceding presentations did a great job of talking about kind of what's going into our atmosphere, but also thinking about the 38 gigatons of carbon in the ocean. And of course, the ocean has, just like the atmosphere, natural cycles that are seasonal, or that are, the ocean is a natural cycler of our carbon. But what we're seeing is that trends are outpacing this natural cycling. So since the Industrial Revolution, we do have the ocean absorbing 93% of excess heat that has been caused by increased global warming and created by greenhouse gas emissions, and also has directly absorbed 30% of carbon emissions directly into the ocean. And what is important, I think, for governments and for all of us as community practice to take away is that has really resulted in consequences, including more acidified, warmer, and less oxygenated ocean, which has consequences for species, behavior, and survival and distribution, and that has a big impact for communities, human communities that are depending on those ecosystem services coming from our ocean, including food. And I think the other thing I want to point out here is that when we talk about the warming targets, there's also sort of this notion of additional targets to think about the impacts of CO2 on our ocean. And so that's something to consider if our warming targets are even enough to think about how we tackle climate ocean change. So we already know the numbers, I'm not going to belabor them. I think what's important, as Michelle pointed out, we are historically unprecedented levels, but that has caused this projection that by the end of the 21st century, we could be seeing acidification 150% higher than we have seen since the Industrial Revolution by this increase of CO2 emissions. And one thing that I want to add to our G's and T's and parts per million is this notion of pH. And so that's, of course, the changes of pH in our global ocean caused by CO2 emissions. And I think what's important to think about is most government makers certainly don't know anything about ocean acidification. And what we really want to describe is that when CO2 meets H2O, that creates this increased hydrogen in the water that bonds with carbonate, that creates a bicarbonate and depletes the ocean of building materials that species need to grow and survive. And as you can see, this is a downward trend, just like we have these color bars thinking about warming temperatures. When we think about climate change communications, we also have these color stripes indicating this global decline in pH. And then importantly, we think about another metric of this carbon emissions on our oceans is aragonite saturation. And aragonite saturation state is a measure of basically how easy aragonite, or minerals that are these building blocks for calcium shell builders, can dissolve in water, or in this context, it's an assumed measurement of the solubility of a particular organism that can, the solubility of a specific organism or species, particularly thinking about shellfish and coral. And so what's really important to think about is that at this metric of 3 or less for aragonite saturation state, you do start to see a lot of organisms become stressed, not be able to grow, not be able to think about their whole life cycle. And then when you see aragonite saturation at 1 or below, that's when you start to think about species that are possibly dissolving or not able to build back when they do have these impacts to coral and to shellfish. And so I think I'm just going to leave it there when I think about what are the global frameworks or international frameworks for thinking about ocean acidification, both from the mitigation and adaptation side. There's a lot to think about at the UNFCCC level, again, whether or not these, ocean is reflected in mitigation and adaptation targets, whether our mitigation and adaptation targets are enough to address things like ocean acidification. Across the Sustainable Development Goal agenda, of course, we have ocean targets, we have climate targets, we have food targets, and that none of these things are really deeply connected in the way that they need to be when we think about policy to both measure but also to address. And so I'll leave it there because I know we're at time, but that is sort of the work of the OA Alliance, is to bring more governments into thinking about what these impacts additionally of CO2 emissions are on our ocean, and why that's both an urgency message to get at our deep reduction targets, but also thinking about the adaptation and financing that's going to be needed at different scales regionally and locally.